This video is over a few practice problems on sorting numbers into either the rational or irrational category. So for these practice problems, we're going to identify whether each number is rational or irrational, and we're also going to explain why. For the first one, number -12, -12 is rational because it is a whole number. Remember, all whole numbers are rational. The second example is pi. Pi is irrational. It is irrational because it is a symbol. All symbols are irrational. Number 3.06 is rational because it is a decimal, but specifically it is a decimal that stops, meaning it ends at 0.6. It does not continue on. The next example, 7/8, is rational because it is a fraction. All fractions are rational. The next example, 0.12345 is irrational. It is irrational because it is a decimal that does not stop or repeat. The dots at the end of the number tell us that it continues on, and it doesn't repeat because all of the numbers are different. In the next number, 0.33 repeating, it is rational because it is a decimal that repeats. The line that is on top of the 33 is our clue that it is a repeating decimal. Repeating decimals are rational. The next example is the square root of 20, which is irrational. It is irrational because it is not a perfect square. We just finished learning about the 15 perfect squares. The closest perfect square would be the square root of 25. We can solve the square root of 25. We cannot solve the square root of 20, so it is irrational. The next example is -1.75, which is rational because it is a decimal that stops. The decimal stops after 0.75. It does not continue going. The last example is the negative square root of 121. It is rational because it is a perfect square. We can solve the square root of 121, which would give us 11.